right, number one, we got 3 parts. It says in a state lottery, a player must choose 9 numbers between 1 and 59. On drawing day, 4 balls numbered 1 through 59 are randomly selected from an urn. Random variable x represents the number of matching numbers. We're going to verify that this satisfies the criteria for a hypergeometric probability experiment and determine the values for n, capital N, little n, k, and also list the possible values for the random variable x. So let's start out with listing all the elements. So big N is the total number, and we have 59 balls that we can choose from. It says a player's going to draw 9, so your sample size, you're going to draw a sample size of 9. And it says that on the drawing day, they're going to draw 4. So there's 4 correct that you can get. And so X would be the number of successes. So out of the 9 in the sample, we cannot draw or get more than 4 correct, because that's what's happening on drawing day. So your possibilities would be 0, because that means you missed all of them. So out of the 9 numbers you chose, none of them were correct, or you could get 1, 2, 3, up to 4, because that's the max. So you will not get more successes than the maximum number of successes in the group. And so according to this, it looks like it could be hypergeometric. So I'm going to say yes, population size is finite. Exactly 2 outcomes. Either you get 1 in the group or not. And then the sample size is obtained from the population without replacement. So when you draw, you're not going to replace them. All right, so it's asking for the values. We're going to input 59, 9, and 4. And then the possible range would go from 0 up to 4 max. All right, number 2, we got 5 parts. So it says determine if the following experiment represents a hypergeometric probability experiment. If it does, we're going to determine values of n, big N, little n, and k. List the possible values of the random variable x. A manufacturer received an order of 250 chips. It says, unfortunately, 10 are defective. To test the shipment, the quality control engineer randomly selects 20 chips from a box of 250 and tests them. The random variable x represents the number of defective. So another thing to note is that, again, success and failure does not always correspond to something positive. When we say success, it could be negative, in this case identifying something that doesn't work. So in this case, our big N, our sample size, is the 250 chips. 250. Let me rewrite that. 250. Our little n says we're going to do a sample size of 20. And it says we have 10 that are defective. So there's 10 that don't work. And so our random variable x could be any number from 0, 1, 2, ... all the way up to 10. Anything between 0 up to 10. Is this hypergeometric? I would say yes. If we're going to test the chips, we're not going to be putting them back. It says select the correct choice. The value of n is, and we're going to put 250. Select the correct choice, the value of k. So there's 10 defective that are in the special group. The value of smaller n, the sample size would be 20. And then the possible values of x would be from 0 to 10. So be careful that 1 to 10 looks like it almost wants you to jump at that, but remember you could possibly identify 0 that don't work.